Imagine a guy holding a bar magnet in his outstretched hand as he sits and plays in an astronaut's gimbal training simulator, tumbling around on 3 variable axes, and the magnet might as well spin like a football in his hands. But first, he scuffed his feet on a rug next to the astronaut's machine to create more of his own net charge. So he's training as a football quarterback playing in AstroTurf for the Chargers. As he tumbles, the Charger player feels a rolling force from the magnet acting on his trajectory, which redirects him based on his inertial mass like kneading a pizza dough. The motion of the Charger quarterback rolling in dough then acts back on the magnet, which is redirected in his own trajectory, whose grip then acts as a dough maker for the Charger, and so on, until forces intercept where the center is unmoved. Throughout the experience, the electromagnetic field everywhere around the magnet is determined from an onlooking referee using both eyes. This would be expected when we see the observed electromagnetic spectrum having a set of primary frequencies, and then a matching set of dimmer frequencies in the secondary further along the harmonic. The ball is thrown, caught, observed. The referee holds the whistle and throws his hands in the air, signaling touchdown. Imagine looking at the ridged lines on the edge of a quarter. Connect the top of 2 lines and the bottom of the next lines to make a single continuous wave. Focus your eyes on that stream as it weaves from one line to the next. This is a representation of what stars do around a galaxy, generating a predictable motion of the electrons within it. Now imagine that quarter between your fingers and spin it while flicking it in the air. As it tumbles, focus again and trace the quarter's edge with your eyes. The electron is an electromassive object weaving between those ridges on the edge of a quarter, with the center being the nucleus. For generations, we wouldn't know the exact tilts of the quarter system because of the speed of the electron laughing at our best instruments. The idea of this math is that if you can see a predictable flow of electrons, say around a galaxy, then reduce the same equation to the structure of an atom, you would still have an equation to recognize the motion of an electron within its cloud around the nucleus. Now take the nucleus out altogether and reduce the cloud radius to 0, leaving nothing but the electron as your center point. The pitch and tilt and weaving would remain as the various rolling angles within the electron itself. It would be an electron mapped rotating on each of 6 or more axes. The vigorous angular momentum of the free electron would be realized before the instrument's fast enough to measure it by itself, done so by a frozen-looking mess through an enormous telescope. The quarter is one end of an accordion. The other end is the observer, a satellite somewhere in space at 2 different times. Since a line between your eyes is difficult to draw in free space where everything is moving, this observer side of the accordion focuses on nearby fixed or nearly fixed objects to develop a tripod. The angle between gravity and object galaxy, the angle from the satellite between the Earth and the Sun, and the angle between the Sun and the center of our galaxy all change with respect to each other, and as the observer travels by them through free space. This is the second end of the accordion. The length of that accordion is complicated by the galactic mess. Imagine a hula hoop with ball bearings rattling inside. As you spin the hula around your hips, the force felt represents the activity of stars in the system. As you go faster, or add ball bearings, the centripetal force activity increases. The same electrons that bind the galaxy also trigger the nuclear reactions. So as discussed in the book, a new coordinate system, like X, Y, and Z, emerges in deep space. The apparent size of a galaxy versus its distance versus the activity or flow of electrons generate a set of axes in a grid. Comparing those 3 elements to each other, the size multiplied by the through flow corresponds to energy, which is at a distance. How is this possible? It's all in the spectrum. After explosions as visible light, ultraviolet rays represent the acceleration of hot protons escaping the star from the electric field. Radio waves around the star represent the velocity of the protons, indicating the strength of the magnetic field. Like a wake behind a boat's propeller, the electromagnetic waves from the most distant galaxies, propelling energy away, continue on even as they are received by satellites around the Earth. Radio waves also represent the speed of the electron flow, while X-rays are the size of the electron flow. This flow exactly depicts the strength, motion, and thirst of the stars within a galaxy as they generate energy, since electron flow depends on the star's strength, motion, and thirst for combustion. The thirst of the stars for electrons, combustion, is also represented by brightness in the visible spectrum. So comparing the visible spectrum to the UV rays, the electric field acceleration, to the radio and X-rays, resultant electron flow, the actual radius of a galaxy can be determined for any orientation. This is free energy, a constant flow of electrons with no extra work after these things build up motion. Oil and fracking is a complete waste of energy. The only thing that keeps us drilling is that scarcity of energy is profitable, and that this work remained unrealized as the planet approached its awakening. Orientation is visual, but based on it, one can compare the difference in shift from one side to the other to give the velocity of the stars as they revolve around a galaxy. All of these signatures elongate with distance, and all of them vibrate at different wavelengths, showing that the speed of light is no constant, and crushing Einstein's constructs. These components equate physical energy to the energy spectrum received in electromagnetic waves. How will we know it's wrong if we never look? How? Imagine a jet plane that can raise or lower its nose, pitch, twist along that pitch axis, roll, or strafe right and left from the other two axes, yaw. Pick a point on that plane. Now as you observe that point as the plane is doing acrobatics, the line changes in length like the accordion analogy. Now if you draw a point somewhere off of that point, that represents the electromagnetic field at angles and distance from the target point. This makes things easy because the electromagnetic field around a standard sphere is a straightforward set of equations for those very angles and radii. Your new point off the plane is the field. But we are still looking for distance, because what we receive depends on how far we are from the new point. To avoid assumption of what the shift in the electromagnetic spectrum means, we have to work with the raw data and leave distance as a variable until it's understood for sure. One problem is when determining the electromagnetic field to compare the observed spectrum line received. There is a line which has the same reception but with many angles of validity from the center of the plane. That line is the exact line of your sight as you look at the object. So roll, pitch, and yaw have several locations at varying radii, at which locations fields are collectively a composite of the received line, the line at which you are directing your vision. A triangle is formed between the line of sight and the point generating the energy, and as the line grows in length, the angles on either end shrink, but never reach a final number. This phenomenon happens to humans all the time. When we look at the stars and try to focus on one particular star, it becomes blurry. But if we look just next to it, it becomes clearer. That's because straight on is difficult to sort, and that's the problem with distance. Worse, as those angles change along a line, the accuracy diminishes as you never reach the angle at an infinitely long line. To resolve this, we have to be moving ourselves, shifting our heads, or traveling in orbit while we narrow in on the target object. Pick a point between your eye and the electromagnetic field or throughout the object. That point is dark, but what's behind it is the composite of all the fields along it emerging from celestial artwork. So what you observe is, say, one of the plane's wings. As you move yourself and try to refer back to that midway point, you're now looking at the hull. So at some point on the first look at the wing and the second look at the hull, the two receptions have an equality. Your two eyes are two different points of observation in a given period of time. Looking along towards the object end, the line integration of this accordion-like varying distance between the observer and the object of preposition, your target, should compare to the actual line received by instruments as you switch between eyes. It should, by expecting the received electromagnetic fields at varying mathematical lengths. Comparing the hull to the wing and setting them equal to each other, you would find the conditions by which every point between you and the object has an electromagnetic field observed. This would clean up the code and allow the observer to triangulate by reviving a sort of parallax a narrow-scale measuring technique first popularized more than 23 centuries ago, but abandoned for other scales, and bolstering it to aid in calculating distance at any scale. By comparing those fields to the received spectrum along the same line, you would determine all unknowns, the first one simultaneously being distance, flow of electricity, and radius for all sizes and speeds of component, mass, and charge. In other words, perpetual energy. Now, it would allow us to take any received line and know its components of elements and the structure by which they exist in the thing at which you're looking, and everything between it and your eye, whether it's a virus, plant, or electrically sensed intruder in the human body, and develop a picture of lock and key to filter out the tumult. As you go through free space, the observer can refocus on the most reliably stationary tripod nearby, switching from one nearly fixed point to another like Tarzan from rope vine to rope vine while traveling through the jungle. Light speed is no limit.